Okay. So if you go out on Canvas under Unit 1, you should see a link to the Chapter 3 practice. I keep throwing more and more stuff out there, I know, so it's fun trying to find it. So Chapter 3 practice. So this week we are going to do examples in Chapter 3 and talk about Chapter 3, and then next Wednesday we're going to do regression project. So that'll be your project for this semester, so you'll get it knocked out and be done with it, right? So we will be using Excel, and we'll do a practice one together in class. So I'll show you how to set up the regression in Excel, how to run a regression, and tonight we'll talk about more about what a regression is and why we use it. Although if you've done the little adaptive learning plan quiz, you kind of already know a little bit about it. It's again just estimating costs, but it's more accurate than some of our other methods. So we will be doing that, and then I'll talk about the project next week as well, so you'll know what to expect. It's really just running a regression and answering some questions. We'll run 2 regressions, actually, a single and a multi-level regression. So as we get through tonight and then next week, hopefully all of that will make sense, and it's not like time consuming. It won't take you like 5 hours or anything. It's not anything major, but it's a good practice in understanding and getting some exposure to Excel for those of you that don't work in it very much. So Chapter 3 is all about cost estimation. So the whole purpose of this chapter is really establishing cost equations and understanding fixed and variable costs, how they work together to calculate total costs. So that's kind of our goal, is looking at data and being able to estimate costs and how costs function. So, they may give us one level of cost, well, these are our costs if we produce this many of whatever we make. But using cost estimation, we can write a formula, a cost function, that we can actually predict costs at any given level of output. So that's kind of our big focus, or our goal in this chapter, is to be able to estimate costs and write a cost function. While I'm thinking about it, on Canvas also, there are, I think I pointed them out in Chapter 2, but there are some Chapter 3 notes. So, feel free to use those. And open it up just real quick here. Just kind of show you. So that first one is just showing the cost, equation or cost function. Total cost equals fixed cost plus variable unit cost times whatever our volume of production is. So again, total cost of producing a product is both fixed plus variable costs. And so when we're looking at, again, establishing a cost function, this is important. So I'm just going to write that on the board as we go through, because we will use it in all of our examples. So total cost equals fixed plus variable unit times number of outputs. Okay. So what we'll learn as we go through and do these cost estimates is a lot of times we're going to know our fixed costs, because that's, our fixed manufacturing or product costs. So we're talking about overheads, rent, factory supervisor salaries, things like that are fixed. And then we'll know our total costs, and kind of what we'll be solving for is getting that variable unit cost. And once we have a variable unit cost and a fixed cost, then we can calculate total cost at any given level of production. And we did some of this in managerial accounting. We're just taking it a step further. So hopefully you kind of remember there's like some main methods of doing cost estimates, which again, our whole goal here is usually to solve for a variable unit cost, and then from there to write a cost equation. And there's the scatter graph which we'll look at when we do the regression a little bit too. But with scatter graphs, you're just plotting on on an actual line chart, total costs and fixed costs, and showing that relationship and being able to kind of predict costs. But it's not super reliable because, it's more visual and there's outliers, right? You kind of read through that in the chapter. So sometimes we have to throw out those outliers to get a better line graph and get a better cost formula. So the second method, which we'll do here in a minute, is the high-low method. So that's on here too. That's when we're looking at, we take the cost at the highest activity level, in a given amount of time, like in months, minus the cost at the lowest, and divide it by the highest activity minus the lowest activity. That gives us, we'll solve a variable cost per unit. And then again, we can calculate and we can write a cost function. So that's kind of our end goal, is we solve for variable cost per unit. In all of these methods, we're looking to solve for variable cost per unit so we can write a cost equation. Okay. So we're going to look at high-low method, which again is a review for managerial. So hopefully it'll seem familiar, because once you calculate a variable cost per unit, you can then calculate your fixed costs. Once you have your fixed cost and your variable cost per unit, then you can calculate total costs at any level of production. So that's kind of, again, our whole goal here is to be able to establish a cost function. And it kind of shows you that. We'll look at this here in a minute. And then, so that's the second method. And then the third method is regression. So this is a new method. We didn't cover it in managerial, or I didn't. I don't think anyone does. I could be wrong, but probably not. It's more advanced. So it actually does, we use a data analysis tool, which in Excel, it's going to do all of the calculating for us. So it's going to take our data and analyze it. And it's going to give us parts of our function. So we're going to tell it total costs, and we're going to tell it the fixed costs, and then it's going to return to us the variable cost per unit. So it's pretty cool. So again, we'll look at that. Or actually, I'm sorry, I said we'll give it total cost and then the variable cost, and it will tell us what our fixed cost and our variable cost per unit is. So it's pretty cool. We'll run a regression later. We're going to look at some regressions today, just kind of analyze them and get kind of focusing on that. So we'll kind of come back to this. But when we run a regression, we get what we call an intercept. Well, our intercept is our fixed cost. Intercept is our fixed cost. And then our variable, we get X, will be our variable unit cost. So we're going to look at that. I wanted to go over that a little bit though. So those are always out there for your help. You need them. So this first example in Cengage, we're looking at just writing the cost equation given the data that they provide. So it says Cali's Gym is a complete fitness center. Runner Cali employs various fitness trainers who are expected to staff the front desk and teach fitness classes, answer the phone, blah, 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 blah. The cost of the fitness trainers is $600 per month and then $20 per class taught. So we have the fixed costs, the $600 per month, and then we're paying them $20 per class that they teach beyond that. Last month, 100 classes were taught. So to figure out our total costs, our total labor costs, we just want to put it in this fixed plus variable form. So this one is super easy. It's just kind of giving you an idea of how to establish cost equations. So it's always total cost equals fixed plus variable. Well, in this case, 600 is my fixed amount that I'm paying, and then I'm teaching $20 variable per class. Okay. So again, this one's pretty easy. It's just kind of getting us kind of, understanding fixed versus variable costing and how it's changing. Number 2 says, what was the total variable labor cost for last month? So what is my total variable labor cost for last month? $2,000. Very good. So we taught 100 classes at $20 a class. Okay. So my total variable labor cost last month was $2,000. Okay, so basically when we're putting this into the formula, all you're doing there, that's your fixed. Variable is $20 and then times 100 classes. So this is this 2,000. Again, this is my fixed. And this portion is variable. Okay. So we're just using that cost equation. So what was my total labor cost for last month? 2,600. Okay, we're just adding it together. Fixed plus variable, 2,600. Number 4, it asks what the unit cost of labor per class was for last month. 26. Very good. 2,600 total costs divided by 100 classes. The cost per class is $26. Well, on 5, it says, what if Cali increased the number of classes offered by 50%? Well, again, when we are able to establish a basic cost equation, we can plug in any number of outputs we want and recalculate total variable and total cost. So here, all they're saying is instead of teaching 100 classes, she taught 50% more. So how many classes were taught? 150, right? So all you're changing there is your output. So it's still 600 plus. Now you're saying 20 times 150. Okay. So there my variable costs would go up to 3,000. And so then my total labor costs are what?
3,600.
Very good, 3,600. Okay. So the next month, if she taught 300, all we'd have to do is plug in that 300 right there and recalculate. Okay, we're just changing levels of production. And so my total labor cost is 3,600. What's my new unit labor cost? $24. Very good. And there we took the 3,600 divided by 150 classes. So now it's dropped, right? Our cost of labor per class has gone from 26 to 24. And why is that?
Because the fixed amount is still the same, but you just added to how many there are.
Right, you're spreading that fixed cost over more classes. Very good. So why did the labor cost decrease? Because your fixed cost per unit goes down. Okay, so you're just spreading that 600 over more classes. And that's important to understand. You know, variable costs of labor stayed the same at $20, right? That variable cost stays the same. So total variable costs go up the more classes we teach. 600, we pay $600 whether these instructors teach 20 classes or 200 classes. But the fixed unit cost goes down with the more that we teach because we're spreading that fixed amount over more classes. Any questions on that one? We start out pretty easy, right? That one. You're like, we got this. If this is all chapter 3, we're good, right? It's not too bad. Chapter 3 is not that bad. So then on to the second one. And here we're looking at Horizon Manufacturing Company has a purchasing department staffed by 5 purchasing agents. Each agent is paid $28,000 per year and is able to process 4,000 purchase orders. Last year, 17,800 purchase orders were processed by the 5 agents. So here we're switching gears just a little bit and we're looking at activity rates and, you know, unused capacity and things of that nature. So it wants us to calculate the activity rate per purchase order. So how much on average, if they're paid $28,000 per year and can process 4,000 purchase orders, what's the cost per purchase order? $7. Yeah. Okay. Talk about cost drivers a lot. So in this case, you know, purchase order is our cost driver. It's driving, you know, this cost to us. And you're just truly taking $28,000 divided by 4,000 purchase orders. So on average, we're paying our purchase agents $7 per purchase order. Okay. Number 2, it says calculate in terms of purchase orders the total activity availability. Well, if they were working at full capacity, how many purchase orders could they produce in a year or process? I mean, 20,000. Good. Because they're able to process 4,000 a year, and there's 5 of them, right? So in theory, they should be able to process in 1 year 20,000 purchase orders. Well, what's the unused capacity? How much are they not producing that they could? 2,200. Good. Because they only produced, or processed, I keep saying produced, they only processed 17,800 last year. They're capable of doing 20,000, but they only had 17,800. So the unused capacity is 2,200. And here we're assuming that 17,800 was what was needed processing. You know, we didn't have a labor inefficiency. We're just assuming that that's all the purchase orders that were available to process. Okay. So they have some idle time, right? I'm sure they're complaining. So what's the total activity availability in dollars? 140,000. You truly just take that 20,000 times the $7. Okay. And how about my unused capacity?
15,000.
Very good, 15,400. So 2,200 purchase orders times $7, 15,400. So basically, we're paying 15,400 in salaries of unprocessed purchase orders, if that's all these people do. So I guess that's our assumption, right? On number 4, it's pretty easy. It's just saying express that in terms of activity capacity used and unused. Well, all total, we had 20,000 available. Of that, we processed 17,800. 2,200 was unused. And then we already processed the total activity availability in dollars. That was 140,000. And we know our unused was 15,400. So what was the dollar amount of the activity capacity that was actually used? Very good, 124,600. And you could obviously subtract 140 minus 15,400. Or you could take the 17,800 times 7. You should get the same amount. So on number 5, it's asking us, well, what if one of the purchasing agents agreed to work half-time for $14,000? Okay. So how many purchase orders could be processed by 4.5 purchasing agents? So if one of our 5, if our 5th employee said, well, I'll just work part-time. 18,000, good. So there you're truly just taking 4.5 employees times 4,000 purchase orders, right? Or however you want to get to it. So if one of our processors dropped down to half-time, what would be our unused capacity then? 200, good. So would that be a good costing decision? Absolutely, yeah. We're going to save, $2,000 worth of, or 2,000 purchase order processes, which is really like $14,000. So by doing that, we'll save a labor cost of $14,000. That's not too bad. It's not too shabby. At least the purchasing agent agreed to work half-time, right? May not be so great for the purchasing agent, but it is a good costing decision for the company. So you can see why if we understand our cost drivers and then eventually we get into capacity and everything, we can make decisions that will help save money. So we could then take that saved labor cost and put it towards, something else in our business. Any questions on that one? Okay. So now on the third one, we're dealing with actually kind of getting into establishing, you know, a cost equation. So we're going to use the high-low method to determine our variable cost per unit. And then from there, we'll solve for a fixed cost per unit and be able to write a cost equation and calculate costs at any level of output. So this is what, Doheny Manufacturing Company. I don't know where they get these names, right? I don't know, it's like, thanks, Engage, for giving me fun names to say in class. We have the following 12 months of data on purchasing cost and number of purchase orders. So we are making the assumption here that purchase orders, the number of purchase orders that we have are a cost driver, meaning that they influence our purchasing cost. So that's our assumption here. So given this data, we have 12 months worth of data showing our purchasing cost and the number of purchase orders processed each month. We don't know, we know this is our total cost, okay? We don't know what our fixed costs and our variable costs are. So basically when I'm looking at this, we know total costs and then we know the number of outputs each month and those change. So to be able to kind of calculate a cost equation or a cost function, we need to figure out our unit variable cost, okay? Once we solve for this, we can solve for the fixed cost. Then we can write a cost equation where once again, we could look at any level of output. You know, we could say number of purchase orders was 700 and we would know our total cost. So that's the end game. So we're going to use the high and low method, the high-low method to calculate this, okay? My hint when you're dealing with the high-low method is always look at the activity driver, okay, when you're looking at your high and low point. So in this case, sorry, it's hard to get it where it's displaying. There we go. I'm going to look at these 12 months of data, and based on the number of purchase orders, I'm going to pick my high month and my low month. Okay. So what is my highest month of purchase orders? August. Good. And in August, we produced what, 560 or processed 560. What is my lowest month? February at 330. Okay. So when you're determining your actual data to use, always go off of your activity, you know, like in this case, number of purchase orders. So not your total cost, but your activity level. So month with highest number you said was August, which is correct. And then the low was February. So I'm going to basically look at just that data. So in August, I had what, 20,940 in costs. And that was with a production or purchase orders of 560. For February, it was 18,065. And the purchase orders were 330. Okay. So to solve for my unit variable cost, the high-low method, you're going to take your cost at the high minus your cost at the low. And then you're going to divide that by your activity level at the high minus your activity level at the low. Okay. So we figure out our high month and our low month based on number of purchase orders. And then I just subtract. So you should get 2,875 over 230. And what is my variable rate based on the high-low method then? Very good, $12.50. So that's the high-low method. So number 2, where it says calculate the variable rate, using that, it's $12.50 per purchase order. On number 3, we're calculating the fixed cost based on that. Well, now what we do is basically, if I look at my total cost formula, if I used any month of data, it doesn't matter. We use usually either the highest or the lowest month of data, but I know my total cost. I now know my variable cost, and I know my number of outputs. So I know all but one, we get to use some algebra here. Woohoo, right? It's not too bad though. We can solve for fixed because we know everything else in the equation. Okay. So to solve for the fixed, once you rewrite the equation, basically, what you're going to do is you're going to take total costs minus your variable costs to calculate fixed costs. Okay. So I'm going to pick the high point, the August, but you could use whichever one you wanted. You just want to make sure you use those together. Okay. So I'm going to take my total costs. These markers are already killing me. I'm going to have to go get new ones. My total cost is $20,940 minus my new variable cost per unit, $12.50, times the number of purchase orders I processed at that cost, so the $560. Okay, that looks like an equals, that's a minus. Okay, so $12.50 times $560 is $7,000. So I'm taking $20,940 minus $7,000. So my fixed costs are going to be $13,940. So to solve for fixed, we take total costs minus our new variable cost per unit times however many we produced or processed, I keep saying produced, and that'll solve for fixed. So my fixed is the $13,940. Are there any questions on that?
My variable doesn't like the 450.
Really? Why is it not like it? That's weird. Check my work again. I was like, oh no. Like we have an anomaly. Like I wouldn't be surprised, but I'm glad it's working. So are there any questions on that at all? Does that make sense? Okay, perfect. You guys are good. So then it just wants us to write the cost function. Well, so total purchasing cost equals fixed cost, $13,940, plus $12.50 times whatever our purchase orders are. Okay. So we have our fixed cost, which we solved for, $13,940, plus variable cost per unit of $12.50, which we solved for, times purchase orders. So now, again, no matter what level of production we're at in a month, we can calculate our total variable costs. We know our fixed costs, and we can calculate total costs. Okay. So on number 5, it says, well, what if next month we purchase process 430 purchase orders? What will be my total estimated purchasing costs for that month? Anyone have that calculated yet? Very good, $19,315. Okay. So again, all we have to do is take that 430 and plug it in right here. So 1250 times 430, and then we add in the fixed cost of 13,940. Okay. On number 6, it gives us a what if. It says, what if we want to estimate purchasing costs for the coming year and expect 5,340 purchase orders? Okay. Well, this is just for 1 month. Okay, that costing equation we wrote was for 1 month. So make sure when we're doing yearly ones that you're going to actually take the 13,940 times 12. Okay, so you want to get a yearly fixed cost because that's just per month. So I would take my 13,940 times 12, which is 167,280, if I wrote that right, plus the 1,250 times the 5,340. So if it says for the year, make sure that you extrapolate out those fixed costs for the entire year, because that is just for 1 month. So what are my estimated total purchasing price for the whole year? $234,030. Okay, thank you. And then it asks, what's the total fixed purchasing price or cost? Well, we calculated that right there, so that's the 167,280. And then it says, well, why doesn't it equal the fixed cost calculated up above? Well, because that's a monthly fixed cost, okay? Because there are 12 months in the year. You're going to see that a couple of times on the practice, and I apologize in advance for the repetition. Like, I like the problem, but it keeps asking us the same thing. Any questions on high-low method? So again, it's just a cost estimation method where you're calculating the variable rate per unit, and then you can establish and find fixed costs and establish your cost function. Okay.
Can you scroll quick?
Do it. I'm sorry. Scroll up. Sure. Absolutely. Tell me when.
Right there.
Okay.
Oh.
Down a little
Got
bit.
the decimal point.
Oh, yeah.
There you go.
Okay. Perfect.
I ran into a similar issue where it said 1250 was incorrect. Like, wait, what?
Right? It's like if you forget that decimal, it kind of changes it, right? Yeah. All been there before. Okay. Any questions at all on high-low? Okay. Perfect. Okay, so that's one, cost estimating. The next one, we're looking at regression results. So again, regression is a data analysis that we're going to run in Excel, and it's going to produce some results. So it gives us lots of different results. I put on your notes kind of what to pay attention to, especially because I closed mine already. And again, we'll talk more about regressions next week when we do an example. But we are going to look at some results. So again, when we get the results, when we run a regression, we're going to get some different results. In fact, I'm just going to show you. I feel like it's just, I'm more visual. So I'm going to show you a sample regression. You guys don't have to do anything. I'm just going to run one really quickly on our practice one that we're going to do. Oh wait, that's the wrong. I don't think I put the file out there yet. Hold on. It's okay. Once I remember where I put the file, bear with me. Okay. This is actually your actual regression you'll be running, but hopefully I can do it pretty quickly. Let me see if it's enabled. Of course not. Okay. We have a little time, so I thought I'd show you. Okay. So let's look at a simple one. So simple regression, we're going to look at, we have, this is broken into quarters. We have machine hours and then the power cost. So power cost is our total cost in this situation, and machine hours is driving that total power cost. So we want to run a regression and figure out what our variable cost is and our fixed cost is given this situation. So power cost is my total cost, machine hours are my variable units of production. So when I run a regression, which again, we'll go through all the steps later, I just wanted to kind of show you what kind of data you get. I'm going to choose my total costs, which are always the Y, and my X, my variable, is always the machine hours, the variable. And I'm going to show it here. So instantly, I run this regression, and there's a lot of stuff on here. You're like, oh my goodness, don't worry, we're not going to interpret all of it. So the big things we want to look at, and kind of what I have in your notes here, number one down here, the coefficients. So the intercept, I would round that, but my intercept is always my fixed cost. So right there, I just ran that, and I've calculated based on this cost data, my fixed cost. And then the machine hours is my variable cost per unit. So it's pretty cool when you run a regression, you can instantly create a cost estimate or a cost function. So it's pretty cool. And then the rest of it is statistical stuff. And in your notes, I kind of talk a little bit about, the results. Again, intercept is your fixed cost, and then the factor or whatever it is your variable unit cost. And then there's just a little bit of information about what the other results mean. The biggest thing we'll look at is the correlation coefficient R, which in this case, the R square or the multiple R is 0.89. They're both positive. So if it's positive, that means that there is a correlation between these. So that means that machine hours is driving our power cost. So when those R's are positive, that means there is a correlation. So it's kind of important we can easily get that information. And then the closer it is to 0 means that there's no or less of a correlation. And then if it goes negative, well, that's bad. But that one was really high, like when we were looking at it. And then adjusted R2 is the percent that there's a correlation. So in mine, the adjusted R squared was 0.77. So there's a 77% chance that, or not even chance, but probability that machine hours are directly correlated in driving our power costs. So it can help us, really dig deeper, because if we are just using the high-low method, we're not really getting if there's a correlation. What if machine hours has nothing to do with our power cost? What if we're just totally wrong? So if we run that data, we can determine that. So we can run data very quickly, as you saw with Excel, to determine if there is an actual correlation. So data regression analysis is really cool. I can do it on multiple costs at one time, which we'll do on your project, and it will tell me, what my adjusted R is for all of those. So I can see, oh, this one's really not driving the cost of power, but these two are. And so it's kind of cool. It's a very powerful tool. Again, there's a lot of others like standard errors and things we don't really get into, or I don't, you can tell there's a lot of deviations and things like that. That's for the data analysis people to figure out. But we still just, even as accountants, can just focus on, is it a positive number? Is it close to 1? Okay, there's a correlation there. And then we could even look at, which we'll look at in one on your actual project, on a scatter graph. Maybe there is an outlier. One month, maybe our machine was down, that month, and so that month doesn't even count. Well, what if we took that out of our regression data? Is it going to change? And it sometimes does. So that's pretty cool. I just wanted to kind of show you that. You'll see that more in your project too. So this is the kind of results though that you get. And your book does talk more in depth on like the standard error and things like that. But anyway, this data here, when that's pretty cool that I can establish a cost function really within what, about 30 seconds? It's pretty fast. So within what we were working on, did I go out of it? No, I hate when it does that. Okay, there we go. They inputted, 12 months of data, the purchasing cost, and the number of purchase orders, and this was what they returned. They've rounded it to the nearest dollar, but they saw for their intercept was $15,021, and then their X variable one, 9.74. So they ran a regression, and that's what they got. Well, again, your intercept is always your fixed cost. So when I'm establishing a cost formula, total purchasing cost for this is $15,021 plus $9.74 times purchase orders. And if you'll notice, since these are static, we all have the same numbers, these are the same numbers from the high-low method even. So if you went back and compared, our cost function and formula, our variable unit cost was $12.50. So you can see it's different. We're getting much different numbers using a different method. Usually regression analysis is your most accurate form of establishing a cost function. Again, we would look at the scatter graph and look for outliers to make sure it was more accurate. But that's why we have such a different variation, and that can change. You're looking at what our fixed costs were like $13,940. Well, now our fixed costs are higher, but our unit variable cost has gone down. Well, that changes how we look at costing. So it is important to try to get the most accurate estimation. So then it kind of asks us the same questions it asked before. What if we processed 430 purchase orders? So on number 2, what is my total purchasing cost or for that month if I processed 430 purchase orders? Very good, $19,209. So we truly just plugged in, right? We took the 430 and plugged it in right here. So $9.74 times 430 purchase orders. And then we added in our fixed cost of $15,021. And then on part 3, they do the same thing that we did in the last one. So, good times, right? What if it was estimating for the whole next year? Well, again, you would have to do the same thing. You would have to take your $15,021 times 12 to get the yearly fixed cost, and then plus 974 times 5340. So what would be my purchasing cost for the upcoming year? Anyone calculate that yet?
232,000.
Very good, $232,264. And of that, the fixed portion would have been $15,021 times 12, which was, does anyone have that one?
180,200.
Very good, $180,252. And it's the same answer. There's 12 months in a year. So I said, bear with me on this. But I wanted you to see, how you create a new cost function based on a regression, and, being able to then establish that and calculate costs at different levels. So any questions on that one? You know me, I get excited about using Excel, for those of you that don't know me. So I'm like, woohoo, we're going to use Excel. Look how fast it is. So much better than typing it into a calculator. It's one big giant calculator. I was making fun of my best friend the other night. We went out Friday night, and what was she saying? She was adding it. Because we took like your micro apps that you take here, we took that together in college. Now, granted, it's been a year or two, but yeah, she was like, oh yeah, I was using Excel at work, and it was something really simple, like a sum function. And she was like, I just calculated in my calculator and then type it into Excel. And I'm like, oh. So then I had to make fun of her, but. I'm like, that's just an auto sum. I'm like, you just have to press one button. And I'm like, just email it to me and I'll do it for you. She's like, maybe you can just like, give me one of your Excel books. I'm like, yeah, I have like a ton of them in my office. I'm like, I'll get you the Excel for Dummies. I don't think she appreciated me. The moral of the story is if we don't lose it, we forget it, right? If we don't use it, we lose it. So, because she used to be really good at it. Okay, so the last one is really, as you can see, very similar, but we're adding another variable in. So we're adding another activity driver. So it says the controller for Doheny Company felt that the number of purchase orders alone did not explain the monthly purchasing cost. He knew that non-standard orders, for example, one requiring an overseas supplier, took more time and effort. So he collected data on the number of non-standard orders for the past 12 months and added that in. So a lot of times that's common. So we're looking at purchasing cost alone. Well, we have two types of purchases here. And like they were saying, this non-standard order takes more time and energy. So it's probably also driving, it's obviously driving that purchasing cost at a different level. So it's important to identify those and be able to break it down separately. So, in fact, what if we just have one person like in charge of non-standard orders? It's kind of important to know the costs associated with this. So again, they just added to their regression. Okay, they ran a multiple regression, which again is so much nicer. You can't really get this data out of a high-low. If you have more than one cost driver, you really have to run a regression. And again, then you quickly get the data. You can do it, but it involves some like serious math. And why? Right? Like why? So in this case, we returned a new intercept. So our fixed costs went down to 14,460. And then we have the X variable one, which is the number of purchase orders. So that went down to $8.92. And then we have the X variable two, the non-standard, is $20.39. So based on the regression, it's actually costing us, more than double to process these non-standard orders. So that's a pretty big thing. Now, they don't give us all of the data from the regression, but I would also assume that the regression showed that both are a cost driver, and so that they're both important. So now we get a new cost formula, okay? Well, now our total costs are going to equal our fixed cost, that's 14,460, plus the variable purchase order of 892 times purchase orders, plus, we just add a next section, $20.39 times our non-standard orders. Okay. So given this new formula, we can calculate next month's costs based on how many purchase orders we're processing, both purchase standard and non-standard. So we're just adding more math to it, really. You're just extending it out, okay? So when we're looking at this one, I'm writing on the board since it's longer. It says next month we have 430 purchase orders and 45 non-standard orders. So we would still go 14,460 at fixed costs plus 892 times 430 plus 2039 times 45. Okay. So we've just extended that cost function, so just more math. So what is my total estimated purchasing cost for the month given this data? Very good, 19,213. And the last one's the same kind of stuff they've been throwing at us, so I'm going to kind of breeze through it a little bit. They're asking to do it for the whole year again. So again, we would just take our fixed times 12 and then change our variables. I'm just going to give you the answer. We've done it. You guys know how to do it. 232,979. And here they're asking to round to the nearest dollar. So when you're working the homework, make sure you just pay attention to what it asks to round to. Sometimes it's 2 decimals. Sometimes they want to go to the dollar. And I know when I was going through it, I wasn't paying that much attention, and I put in the 2 decimals, and they're like, it's wrong. So, you know, I guess, pay more attention than I did. And then the total fixed was 173,520. And again, 12 months in a year, 173,520. So that's going to be a multiple regression. So we're going to have a bigger cost function. Again, we could have a third or even a fourth or fifth, cost driver, but it's just for that one cost. In this case, it was, purchasing. So whatever is driving purchasing, we would want to include in this. Okay. So we may have other costs that are driven by other activities. Are there any questions on any of that? Chapter 3 is not too bad, I don't think. Hopefully you guys don't either. Just really the high-low method, a little bit of the scatter graph and activity drivers and regressions. You won't have to do a regression in the homework. So we'll, again, next week we'll come in and, start off with any questions in chapter 3 if you have any from doing your homework. And then we'll do a practice regression. So I'll show you how to get it set up in Excel so you can run it here or at home. I think it's the same instructions on 2013 or 2016 Excel. So not too bad. I put instructions out on Canvas, but it's kind of lengthy. And as you can see, I did it really quickly. So I think it helps if we just walk through one together. We'll all do it together, and then you'll be able to run regressions and kind of do some analysis. It won't take long, your projects. Like I said, you may be able to do some of it in class even. So kind of the nice good time of the class when things aren't crazy yet. So. And then we'll move into chapter 4 the week after. Okay. So all that's due this next week, you have your chapter 2 homework due tonight, and then all that's due next week is your chapter 3 homework. Okay. Any questions? We're done. I'm done early, which never happens in cost accounting. You guys are that good, or you're just nodding along. I don't know.
Yes.
I like it, yeah. Take it as you will, right? Okay, well, if you guys don't have any questions for me, have a great week. And I will see you next Wednesday. Feel free to email me if something comes up and you have struggle with something.